Hello everyone, this is Dr. Bart. I hope you've had a good first day of class. I've had a few similar repeated questions in my temporary office hours today, and I wanted to cover this material just a little bit. You're going to see it again on Friday, and you're going to see it again on Thursday, but I wanted to make sure that you had a chance to hear it from me. Now, everything I'm going to tell you is covered very well in the textbook, so make sure you crack open the textbook and skim through it. But just at a high level, let's go over some stuff. First of all, I want to cover this idea of atomic expressions. So, atomic expressions, things like numbers, 47, 3, 132, negative 5.4. Those are examples of atomic expressions. Also includes strings and images, not necessarily relevant for today. But when we've got atomic expressions, we can use them in compound expressions. So, we have compound expressions such as, for example, ones put together with plus. 5 plus 5 is a compound expression where we're combining two atomic expressions. 5 and 5, that makes 10. The result would be substituted. Multiplication is another compound expression. 3 times 2, we've got 3 times 2 is 6. That would generate a new thing. And you can even make compound expressions from other compound expressions. So, let's do 3 plus 1 plus 2. That would compute 1 plus 2 is 3, add another 3 is 6. So see what I'm doing here is I'm evaluating these inside out, just like we were back in algebra class, and we end up with some value substituting for the whole thing. Now, this plus, this asterisk, the minus, the division, these are all operators. These are all function calls. And the parentheses here are very important for those. Now, Racket has some built-in ones, but we've also got the ability to make our own. When we make our own functions, we have to follow the design recipe, and it has a few important stages. First things first is the signature. So let's make up a problem for ourselves. We're going to say I want a function that can calculate the amount of taxes the amount of money I make adjusted for taxes. We'll say the tax rate in Virginia last year was 15%, and we'll adjust our income based on that. So first things first, we need to write the signature of our function. I write a semicolon. Semicolons are comments in Racket. Everything after this is ignored by the computer, but humans are going to read it. So I have a semicolon here, and that allows me to then put in the signature. We'll call this calc taxes owed. Rate. We'll call this taxed income. I have the name of my function, and then I say that it's going to consume a number and produce a number. Great. That's our signature. Then we move on to the purpose. The purpose of this function is to consume an income, reduce it by 15%. That's the tax rate in Virginia. And return and produce the modified income. Alright, so we have our purpose now. And this is usually something that's given to you directly at this point in the course. They're just going to be giving you these purpose statements, and you'll usually just paste it in there. Moving on from that, I'm going to make some example function calls or some tests. When we want to write tests in Racket, we use our new friend called check_expect. This is a built-in function, check_expect, not check_expert, it's check_expect. And it requires a function call and an expected output. So we have our function name, calc taxed income, and it needs to take in a number. So let's give it a number representing our income. We'll say that I only made 10K last year. Not great, but that's the life of a professor. And I then have to calculate what it is reduced by 15%. Oh dear, I should have picked an easier number. We're the programmer. We're in charge of this. I'm going to arbitrarily choose an easier number. So now we're dealing with 100. 15% off of 100, assuming I'm doing this right, is 85. So, my expected end result here should be, when I call calc tax income and pass it 100, it gives me back 85. Those parentheses are not just there to make it look good. They are a critical part of calling the function. Let's do another test. You should always try and have a few different tests. Always a good idea. We call our friend checkExpect. We call the function that we're writing. And we need another test value. We'll go with 0. And we'll say that returns 0. So now we have two tests that we can work with. At this point in time, if we try to run our program, we get an error message, and it say, oh, you haven't defined calc taxed income, but you're using it down here. So the next step before we run anything is to define our function. We do that using the define keyword. Note how it has parentheses surrounding it. This has a particular format to it. We give the name of the function, which is calc taxed income. And then we need to give it a parameter. The type of that parameter is going to be a number. And the purpose helps guide us. It consumes an income. So that's a great name for our parameter. Calc tax income consumes one parameter named income. We are then free to use income anywhere inside the body of our definition. We have an open parentheses over here, so we'll need a closed parentheses over here. And inside, on the next line, we're adding the body of our function. So, we need to create some expression that represents this. And this is where we need to start thinking a little bit about math. Mathematically, the formula that I'm trying to capture here is the income minus 15% of my income. If I make $100, it's $100 minus 15% of 100, resulting in $85 total. So, in order to translate this, we need to do a few different things. First, we're going to put some parentheses around it to make everything unambiguous, makes everything clear. Then, we need to start fixing some things. There is no of operator, but there is multiplication. So now we've got our asterisks there. We can't do 15%. We have to do 0.15. Boop, boop, boop. Finally, because this is racket, we flip the order of the operator. It always goes at the front. So we end up with multiplication 0.15 times income and, believe it or not, minus income. And this is our body expression. Notice how it relies on the income that we took in as a parameter. So we'll copy this up here. At this point in time, with our successfully written body, making sure I finish all my parentheses, I should be able to run this, and I'd get a nice little message saying both tests passed, and I'd feel really good about myself. If I made an error, it would try and show me the numbers and say like, oh, you know, you're off by a certain amount. But we have this much information here. So, we have it here. One last thing I want to go over that I think is very important is terminology. So, at this point in time, you're going to have some memorization of stuff, some important things to recognize. You have at the very top here your signature of your function. A signature is composed of the name of the function and its parameter types and its return type. We'll talk a lot more about those down the line. Over here we have the purpose. All of these so far are all comments. And then the first line of actual code is here. The whole thing is the function definition using the define keyword. Inside of that, we have the header. The header is composed of the name of the function once again and any parameters. This function only has one parameter. Its name is income. Then we have the body, which is composed of function calls. Specifically, it's got two function calls inside of it, one for the minus operator, one for the multiplication operator. It uses the number, the literal value, 0.15, and the variable's income. It uses the income variable twice. An income variable is also a parameter. It's both. It's allowed to be both. Down here we have our tests, and we have 2 tests. A fine number of tests for this problem. We use check expect to do so, and inside of that we have a function call. So make sure you know what this is. This is the function call. It requires the name of the function, an argument. Let's make sure that that's clearly articulated. The argument, the name, and, this is not optional, the parentheses. In mathematics, we often ignored parentheses. But let me tell you, they're critical in Racket. They define most of the language. If I just start adding in random parentheses, it's not going to work. You have to be very intentional about them. Parentheses indicate a function call. So you notice when they're in front of the minus sign, it becomes a function call. If you put parentheses around this 0.15, it thinks it's a function named 0.15, which is silly. So we don't want that there. So once you go through this, hopefully you feel a bit more confident about completing questions 3 and 5. Whenever you have a function, whenever you need to define a function like this, you define it, and then you write some tests that call it, and those calls make sure that this is actually working correctly. In the same way that I can tell you, hey, go to the store and get me some coffee bread, versus actually having you go to the store. Until I actually call it, until you actually execute the actions, none of the insides of this definition happen. So, you want to make sure that you're always writing tests for each function you define. We're going to cover all of this again. This is not the last time you're going to hear about this. I just want to make sure that if it wasn't coming across from the textbook, you got some information. Feel free to ask any follow-up questions on the Piazza. I'll try and be around until 10. Otherwise, good luck.